Hello, my dear students. Welcome back to the lecture. So here I'll take you a few more assignments so that we'll get a complete understanding. So I think in the previous lecture, I explained you how to understand such drawings. Okay. So I think there won't be any problem. Now let me take one more thing. I'll ask you one question. Can you explain me this particular drawing, how we are going to do this particular drawing, how we are going to understand? I think I'll go with this drawing. This drawing. So we'll give you one drawing, okay, just to make you understand. That's it, okay. Will not do, but since I have not taken the extra bar portion, I'm taking that. So I think I'll go with this bar. Yeah, this seems to be good. Tell me for this particular bar, that is GB16. So GB16, how we are going to do? Very simple, okay. So first, this is my, I think this is my top bar, and this is my bottom bar. So top bar, it is written 16 diameter 2 bar, it will go completely. And this is your left extra support, this is right support, and in the right I'll provide another 16 diameter 1 bar, and 16 diameter 1 bar I'll provide on the right side. You're able to understand how we are going to do? If this is my beam, I'll draw it like this. Yeah, so if this is my beam, I'll provide a 16 diameter 2 bar completely first. So this is top, no, this is 16 diameter 2 bar which will go completely. Okay, great. Now after that, 16 diameter 1 in the first layer only. So again, I'll provide another 16 diameter 1 bar, which will be like this. So this will be in the 16 diameter 2 bar will be outer, will go completely. This bar will be in between, only this much length. This length will be mentioned in the drawing. Similarly, on the right side also it is 16 diameter 1 bar. So again, this will be my 16 diameter 1 bar. Okay, good. Now come to the bottom. In bottom, you are supposed to provide a 16 diameter 2 bar. So in the bottom portion, this will be my 16 diameter 2 bar. Got it? Rest, your so near the support, it is 8 diameter bar at 100 mm center to center. And at the center, it is 200 center to center. Understood, no? So if you understand this, I feel rest all drawing you can do. But again, I told it will be difficult for you to come and do the BBS for this building. Then you have to check all these dimensions and all. Will not do. But I have given you an idea how it has to be done. Okay? So that's how it is. And I think... just in case if you want to do the BBS of this, if I ask you to do the BBS of this, so all these things will be a continuous, okay? So if I ask you to do the BBS of this particular beam, so you'll be putting a continuous bar like this. From here, if you start, your bar will go continuous till here, okay? Your bar will go. And from here, it will be like this. From here, it will be another bar going in this way. Getting my point? It will be a continuous support, like something like this. Practically, if you ask me, so practically how it looks, so it will look something like this. These are those things practically, okay? See, you can see one support, two support, bar passing by. You can see here this thing, okay? So practically all these things, this is how the BBS will be done. All these things I've covered in my how this execution is done and all. I've explained in my site engineer and the construction methodology course. Good. So one thing I've cleared. Now I'll take you to one more drawing. Just look at this drawing. We'll try to take out okay. Suppose now this is one more project what I have. So if I ask you to find the bar bending schedule of this, can you do? It's very simple. What you do? First try to find this thing. What is that? Top straight bar. I mean, first we'll start with the bottom straight bar. So it's written here. 20 diameter 3. It's written throughout. Throughout means in the complete from x1 to x4, this bar will go completely. So this will be a bottom straight bar. Okay. This bar will be your bottom straight bar. And what is this diameter? It is mentioned. 20 diameter 3 bar, 20 diameter 3 bar, 20 diameter 3 bar. Finish. Your bottom portion is done. You know to prepare the BBS for this. This span, then this and the development length, this portion and the development length, you know. Now come to the top. So in the top, they are mentioned 20 diameter 2 bar plus 16 diameter 1 bar throughout. They are mentioned 20 diameter 2 bar, 16 diameter 1 throughout. 20 diameter 2, 16 diameter 1 throughout. So how we are going to do? It's very simple again. So how we are going to do that? So we'll run our 16 diameter, we'll run 20 diameter 2 bar first. So this is my 20 diameter 2 bar. So this is my 20 diameter 2 bar. Okay. And in between this 20 diameter 2 bar, I'll put 16 diameter 1 bar. Always remember the bar whichever is larger in size, that will be at the outer. And the bar which is lesser in size, that will be at the center. You're getting my point? So 2 bar will be at the outer in between this, yeah, in between this, what will happen? My 16 diameter bar will run. Okay, that is what we mean by 20 of 2 and 16 of 1. Apart from that, apart from that, they mentioned here 20 diameter 2 bar extra again, 20 diameter 2 bar extra again, 20 diameter 2 bar extra, 20 diameter 2 bar extra, 20 diameter 2 bar extra, and 20 diameter 2 bar extra. How do you identify that? See, you can see a small, this thing, dash here. You can see dash here, here, then dash here and here. So this is your 20 diameter 2 bar extra. I'll give a different color. So this will be a top left extra. Understand? Then this will be a top right extra. And then this will be your junction straight bar. You know how to find the cutting line for this. This will be a junction straight bar. That's it. Finish. BBS is ready. You know how it has to be done. Again, here all the dimensions has been given from center to center. So make sure you are deducting we are concerned with from column inner to column inner. Make sure you're deducting half of the column from here and half of the column from here. And this complete length you can take. Got it? No? Now come to this thing, stirrup part. So stirrup, what is mentioned? Stirrup again, same thing, same criteria. Here it is mentioned you have to provide a 8 diameter 2 bar at 100 mm center to center. Here also 8 dia at 100 mm center to center. Now, one question is that how far? The distance they are not mentioned. What these people have mentioned? They have mentioned 2D. What do you mean by 2D? 2D means they are not mentioned the distance. Can you see the distance here? No, not given. Earlier case they are given. So when you give when you get something like that, 2D means whatever is the depth of your beam, no, 2 times that you have to do. For example, this particular beam, I'm considering the depth of this beam is 450 mm. 4, 450 mm. So what is 2D? So 2 into how much? 2 into 450 is 900 mm. So that's simple. So this length will be 900 mm. This length, this length from here to here, it will be 900 mm. Again, from here to here, it is 900 mm because depth is same, no, throughout. So 2 into 450 is this one, 900. This is 900. This is 900. This is 900. Pretty simple. Good. Now you'll ask me one question. Sir, if that is the case, what about the middle? Middle is very simple. You know the clear span. You know this clear span. You know this clear span, right? So in this clear span, if you deduct this, how much? 900 from here, and if you deduct the 900 from here, whatever distance is left, that will be your center distance. That easily we have calculated, and you can apply the same logic. You'll get the middle portion. Got it? So this was a bit tricky one, not tricky, something different what we had seen earlier case, because here that distance was not given. So in that case, you have to apply the formula 2D and 2D. Got it? Very simple. Other than that, rest all things you can do. Okay, I'm just scrolling down. You can take a screenshot of this. Take a screenshot of this. Great. Anyhow, this is already uploaded. You can take a down. You can download and you can try to do a BBS for this. Okay, this is actually a G+2 building, I guess. Yeah. So it's a G+2 building, which already I've explained you. Fine. So I hope this is understood to you. Next, I'll take another drawing. Yeah. I'll take one this thing. This is one of the airport project. Okay, this is one of the airport construction project. So here, I think, yeah, here I don't have proper this thing BBS. I think we can, yeah. Here again, same thing. This beam reinforcement is given. You just go through that and you can do the BBS. It's very simple. See here, these people have given a cross section like this. That this is your 16 diameter 4 bar and bottom also 16 diameter 4 bar. And your stirrup is 8 dia at 150 center to center. It is given R beam RB1. So where is your RB1? My RB1, that is roof beam 1. So RB1, I think I need to check for RB1. So where is my RB1? So here it's not visible. Okay. Yeah. Anyhow, it is not there. Okay, it should be somewhere here. RB1. Here also it is not there. No problem. But you know how it has to be done, no? Suppose if I take this, for example, tell me how you'll do the BBS for this. So what is written? It is written B3 here. So B3 beam, they have given the dimensions here. Like B3 beam. So if you're doing this is beam B3. Okay. They have given, see, again, you have to understand one more thing. See here, what is mentioned at support and at mid span. And how do you understand this? Can you understand this drawing? How the BBS has to be done? So it is written at support. That means at support you have to follow this, and at mid span you have to follow this. I'll show you how it has to be understood. Now what I'll do, I'll draw a cross section here. Okay, this is my beam cross section. Okay, good. So this will be my support. This also will be my support, and this will be my mid span. So what is written at first? Always, whenever you get a drawing something like this, first start with the mid span. So in the mid span, 20 diameter 2 bar is shown. So whenever in the mid span 20 diameter 2 bar is shown, it means it will go continuously. So this 20 diameter 2 bar will go continuous. So this is top, no? Yeah. Now come to the bottom. Bottom what is shown? 20 diameter 6 bar they have shown. What is that? 20 diameter 6. Out of that, 1, 2, 3, 4 are in the bottom and 2 are in the top layer. That is in second layer. So again, I'll draw this 20 diameter 4 bar in the bottom. So this is my 20 diameter 4 bar in the bottom. This is in first layer and this is your second layer. Again in the second layer, they have mentioned 20 diameter 2 bar. This is 1 and 2. Now how we are going to draw? This is bit interesting. How you do that? This will not go completely, okay? This will not go completely. If you remember, I had shown you one curtailment, no? This is called as bottom curtailment bar. Remember, no? If you don't remember, which project? Yeah, this AutoCAD project I had shown you. This one. Remember, no? Here it was something like this. See, this one. This is that curtailment bar. Okay. This is in second layer. So the bottom one, which is written 16 bar 2, THO means throughout. Extra means six, that is called as curtailment bar. The same thing I have drawn now. The same thing I have drawn now. Where is that? Yeah. Got it, no? This is how it looks. Very simple. So once you finish the mid span, now come to the this portion. Now it is written 20 diameter 6 bar. In that, this outer 2 bar is already covered. You see here. See, if you're finding it confusing, no, it's very simple. It's just a matter of time. You'll learn all these things. So this 20 dia is in the middle span, which you already shown. That means this 20 dia we have taken care of. This 20 dia we have taken care of. Now, in my top left extra, this and this bar I need to show. And this bar I need to show. So again, what I'll show in this longitudinal view, again, I'll show here 20 diameter 4 bar, 20 diameter 2 bar. Okay, it will be here only. I'll show like this. I'll show like this. So when I show like this, it means there's actually another 20 diameter 2 bar going. Plus in the second layer, again, you have to provide 20 diameter. So this is my second layer and this is my development length. Got it? So this is my top left extra. This will be my top left extra, but it is in the second layer. Getting my point? And this is already one bar is there. That means how it looks, no? Out of this 6 bar, you have 4 bars in the, so it will be something like this, 4 bar. 1, yeah, 1, 2, 3, 4 bar. Out of that, this outer 2 bar will go completely, whereas the middle 2 bar will only go up to a certain distance. So that distance, it will be mentioned in the drawing that we had seen earlier and all, no? That drawing will be mentioned. So that is why I told the longitudinal beam has to be given. This distance will be mentioned. Then along with that, in the second layer in the bottom, again 2 bar will go. Again 2 bar, which is that 20 diameter 2 bar will go. How long it will go? It will go, I mean, how far it will go? Again, that length will be mentioned. It will be given like this. Simple. So this is at support. This is my left support. Same thing you'll do on the right support. Same thing you'll do on the right support. Again, on the right support, what I'll do? I'll take this color. So again, this, it means this is a 20 diameter 2 bar plus your top right extra will come. This is your top right extra. Okay, fine. That's it. Understood? This is how you're supposed to do the longitudinal. I mean, the AutoCAD guy will prepare a drawing something like this and give. And after that, you should do the bar bending schedule. So these things you need to develop certain skills after some time. If you understand the fundamentals, this is very simple. Got it? No? So I've taken this case study also. I hope you have got an idea how it has to be done. Okay, fine. Now, other than that, I think most of the things I've taken care of. I've explained you. Okay. And now I'll go to one of the this thing. What is that? Another one beam I'll go. PDF part I've taken care of everything. I'll go with another one bit complicated, which is about the side face reinforcement. Okay. So side face reinforcement is here. Where is that side face reinforcement? Yeah, this one. Okay. This is another industrial project. This drawing is one of the industrial project. We have all the beams like B1, B2, B3, B4, B5 and all. And for that, this drawing is given. Okay. And for this, if you prepare the bar bending schedule, how you will prepare the BBS for this? Just imagine how you will prepare the BBS for this. This is left hand span. That is, when they say left hand span, it is left support. This is your middle span and this is your right hand span. Okay. So always when you get a drawing, of course, you'll get the longitudinal view of this, but still you should know how to read the drawing. So it is written 16 diameter 2 bar. Always middle span will bar will go completely. So 16 of 2 and 20 of 1 will go straight throughout. Then your left extra will be 20 diameter 2 bar again. Then again on the right it will be 12 diameter 2 bar again. Getting my point? Then in the bottom here it is a 16 diameter 2 bar and this one is a 20 diameter 1 bar. 20 diameter 1 bar. So this is top and this one like 16 dia 2 bar and 20 dia 1 bar will go completely in the bottom. And only the middle portion, that curtailment bar what I told, there you will provide 12 diameter 3 bar again. Getting my point? This is how the BBS has to be done. So anyhow, I'll do this. I'll make a cross section of this. Okay, no problem. I'll do it. What I'll do, no? I'll draw a beam. I'll draw a beam. I don't have space here. I'll draw it here. Yeah, yeah. Imagine this is my beam. Okay. Then again, this is left, this is middle, and this is right. So first always go with the middle. It is written 16 of 2. So which is 16 here? This is 16, this is 16, and the middle is 20. So what you'll draw? You just have to draw one line to differentiate. So this is my 16 dia 2 bar and 20 dia 1 bar. So you're getting my point, no? So my 16 dia 2 bar will be like this. This 2 is my 16 dia 2 bar. In between that, I'll provide a 20 diameter 1 bar. Now you'll ask me one question. Sir, you told bigger diameter bar you have to keep outside. Actually, you have to keep in that way. But here, since we have only 120 diameter bar, we'll keep it inside. And 16 of 2 bar will keep outside. Done. Now come to the left hand span. In the left hand span, it is mentioned 16 diameter 2 bar. This is already provided. Here also it is mentioned on the right support 16 diameter 2 bar. This is already provided. That is why 16 diameter 2 bar has gone completely. But again it is mentioned 20 diameter 3 bar. So out of this 20 diameter 3 bar, 20 diameter 1 bar in the middle it has been completed. That means I need to provide 20 diameter 2 bar. I need to provide 20 diameter 2 bar in the second zone, in the second layer. This will be my 20 diameter 2 bar in the zone number 2. This is second layer, okay? So you can see 1 and 2 bar, no? So that is why this is 20 diameter 2 bar in the second layer. Similarly, here it is 12 diameter 2 bar. Here it is 12 diameter. Here it was 20, but here it is 12. So this will be my 12 diameter. This will be my 12 diameter 2 bar. Getting my point? Huh. I hope now you are able to understand or visualize what I'm trying to tell. Got it, no? Very simple. Now come to the bottom. Bottom, again you have to start from middle only. Middle it is mentioned, I mean bottom you need to check into the support part. So 20 dia 1 bar and 16 dia 2 bar. So bottom what I'll do, I'll provide 16 dia 2 bar. This is 16 dia 2 bar. Along with that 16 dia 2 bar. In between that I'll provide one 12 diameter. Got it? Finished. Bottom is done. Now again, this is done. This point, this all three are covered. This three are covered. This three are covered. Here also all the three have been covered. But again, you can see 1, 2, and 3. So what is this bar? This bar is actually 12 diameter 3 bar. Okay, this is 12 diameter 3 bar. So they are curtailment bar. So again, I'll provide this 12 diameter 3 bar. So it will be like this. This is my 12 diameter 3 bar. Okay, so 12 diameter 3 bar will be above this bar. Got it? And then the stirrups they have given. So stirrup, what is mentioned? 8 diameter 2 leg, 15 number of stirrup you have to provide at 100. So this first 100 indicates the left support. Again at 150 is middle. Then again 100 is right. That means, so this is my support, no? This is my left support. 1, 2, 3, 4, 5 I'll draw. Again 1, 2, 3, 4, and 5. Let us consider. So this is my how much? In the drawing, what is mentioned? Read it out. This has to be 100 diameter and 100 diameter. Okay. So this will be 100 diameter and this also will be 100 diameter. And middle, they won't write middle and all. It's written 100 plus at 150. At 150 means your middle portion. So your middle portion, whatever you have, no? Yeah. This middle portion, whatever you have, no? This will be at 150 center to center spacing. Got it? So you see what all kinds of drawing you're going to get. So this is industrial projects. In the industrial projects, your reinforcement will be heavy. So this is how the BBS has to be done. So again, method of doing is same. That cutting length remains same, but understanding this will take you time. That's it. Simple. So if you understand this, most of the part I have covered. After this also, if you still have doubt, you can always get back to me. I'll be there to solve your doubt. Now we'll go to the last complicated beam. That is this called a side face reinforcement. What is that? Side face reinforcement. Now, what changes you can see in this particular beam to the one what we did previously and to the one I'm looking right now? What differences you can see? Top, this is top bar, top main bar. This is bottom main bar. Along with that, you can see 1, 2, and 3, 4. So this is called a side face reinforcement. So whenever you have a beam greater than 750 mm depth, in that case, you need to provide side face reinforcement. So usually what happens is that since your depth is more, and we know this is my neutral axis. My neutral axis will be somewhere here. My neutral axis will be somewhere here. Okay. And this part is in compression, compression. This part is in tension. That we know from the fundamentals. The part above the neutral axis is called as compression and below the neutral axis is tension. And below the neutral axis will be having a concrete also. So there, your concrete is strong in concrete is strong in compression, weak in tension. So your bottom portion, you have a lot of tension. Even though you have provided a steel to take care of the tension, but there's a large chunk of concrete. When I say large chunk of concrete, this depth is very high. This depth is very high. This depth is very high. And since entire mass is concrete, there's every chance your concrete can break there. So in order to avoid that, what we do, we provide side face reinforcement. So this reinforcement 1, 2, 3, 4, what we have provided, it is called a side face reinforcement. Got it? That is the main idea, providing a side face reinforcement. Nothing you have to do. This side face reinforcement I'll show you. Practically I don't know, but I'll show you here itself. In this side face reinforcement means in this bar, at this region, I'll provide one bar which will go completely. I'll put side face reinforcement here. He will pass one bar which will go completely like this. Okay. It will go completely like this. It's called a side face reinforcement. That's it. How do you find the cutting length of this? Very simple. You take the distance from the outer of this column to the outer of this column, minus one cover from the left side, one cover from the right side. Finish. Your cutting length is done. You multiply that by number of part, you get the answer. Very simple. Okay. This is called as side face reinforcement. So usually when the depth of the beam is greater than 750 mm, you find such bar. Okay. And if you see here, the depth of the beam is greater, no? The depth of the beam is 900. So that is why the side face reinforcement has been done. So in 1 to 4 bar, we are supposed to provide. And how those 4 bars will be provided? 2 on one side, 2 on the other side. Like practically, again, if I want to show, I'll show here. Practically, I'll go with this. Okay. This is one face, no? I think I cannot show you the face. Okay, I'll show you here. So one bar you will provide on this stirrup. This is one. Below that, you will provide another one. Okay, this is on that side. And on this side, I'll provide another two. This side is here. This side one, and next to that, below that, we'll provide. Fine. This is called a side face reinforcement. So overall length you'll be knowing. You know how many bar you have provided. Two on this side, two on this side. So number of bar will be four. So the total cutting length into four. Cutting length of one bar into four will give me the total cutting length. And how you'll find the cutting length? Just whatever is the length of your span. Whatever is this length from this outer to outer, minus one side of cover from here, minus 40 from the right side, minus 40 from the left side. Finish. That's it. Finish. Got it? Try to do these things. If you have confusion, get back to me. That's it. Yeah, I think most of the things I've covered. Everything is covered. I don't feel there's any confusion that is left for you in order to do the BBS of this. You try to do the BBS anywhere. If you get stuck, get back to me. I'll clear your doubt. Last one is about the cantilever beam. How you are going to do the BBS for the cantilever beam. So for that, what I'll do, we'll go back to this. Okay. So here we have this. Here it's written cantilever. So cantilever is nothing change. Okay, same thing will come. So what is cantilever BBS? Nothing. In cantilever, what happens if this is a scale? So cantilever beam is if this is beam, this is a fixed support. When I put a load, this scale will try to lift up. Okay. So what will happen? You'll be getting the top reinforcement. You'll get more top reinforcement. That's it. I'll show it here only. Okay, now I'll take this drawing only and I'll explain you. Hmm. Cantilever, no? Yeah, this is your cantilever beam. Okay, fine. So how to understand? This is your top reinforcement. This is your bottom reinforcement. So top reinforcement, you see, you're providing a 16 diameter 2 bar. Top 16 diameter 2 bar I'll provide. And in the bottom, I'll provide a 16 diameter 2 bar plus, wait, I think, yeah, correct, no? Which is top and which is bottom? Yeah, this is top and this is bottom, correct. Hmm. Good. So 16 diameter 2 bar at the top, 16 diameter 2 bar at the top, 16 diameter 2 bar in the bottom. Along with that, I'll provide 16 diameter. Ah, yeah, wait. Yeah, top, no? Top 16 diameter 2 bar and bottom 16 diameter 2 bar. And yeah, good. 16 diameter 2 bar at the top and 16 diameter 2 bar in the bottom. Along with that, in between that, you'll provide another 16 diameter 1 bar. Okay. In that way, you're going to provide. Got it. So again, doing the BBS is very simple. There's no changes in that. But one thing, this is not completely clear. Extra they have written. Bottom extra they have written. So I think this should have been top and bottom. Because usually what happens, no? Usually what happens, I'll draw a cantilever beam and I'll explain you. Okay. This is my beam, cantilever, and this is my support. Okay. So usually what happens on the top, you'll get a lot of steel because negative bending moment will be more there, no? So you'll get a steel something like this. You'll get a steel like this. It will go. It will go like this. Okay. And in the bottom, it will be something like this. In the bottom, it will be like this. It don't, bottom bar doesn't have to come here. The bottom maximum bending moment will be here. This bar will be something like this. Okay. This bar something like this. It will go to the top. Okay. It will be like this. Got it. So this top you can write. This top you can say. It will be, let us say 20 diameter 3 bar. I'll write 20 dia 3 bar. Okay. Your top one. And this one. And this one you can say. This one you can say how much it is. Let us say 16 diameter 2 bar. Okay. 16 diameter 2 bar. Simple. Got it, no? Then you can do the BBS for this. Very simple. What you'll do, you'll again measure the distance from here to here. Length you measure From here you deduct one cover. That is a here there is no column, no. This is beam. So beam cover will be 25 that you deduct. Then this will be your length which will go in the column. Whatever is your column dimension, from there you deduct one cover. So this you are going to get. And this complete length is your development length. Total development length minus the horizontal part, you will get the vertical part. Cutting length is done. Horizontal, then the bottom bar also same thing. Bottom bar up to here, you calculate the straight length, and then you add this horizontal and you add this vertical. The cutting length will be found. So this is how a BBS for the cantilever beam has to be done. Got it, no? Other than that, rest all things will be very simple. Great. Fine. Everything we have covered. There's nothing left. In spite of this, if you still have doubt, you can get back to me. One thing I want to tell, sometimes what happens is that, yeah, take this as an example now. Take this beam as an example. Take this beam as an example. So in this beam, you just observe at the stirrup. What these people have told, you have to provide a two-leg stirrup at a 8 mm at 200 center to center spacing. That means there is no zoning. It's not telling from here to the left up to this distance, you have to provide it 100. From here to here, it has to be 100. Middle, it has to be 150. It's not telling like that. It's saying throughout, from this outer to this outer, you have to provide a two-leg stirrup, 8 mm at 200 center to center spacing. In that case, how you are going to find the number of stirrup? You just have to take this length. From here to here, you take the length. So here the length is how much? Can you find the length of this? So I think I can find the length of this. I'll take a dimension from here. Let me measure that. Yeah. So the length is 5816. So what I'll do, 5816, 5816, 5816. I'll divide by the spacing. Spacing is how much? 200. Try to do it manually. Tell me how much answer you'll get. So it is 5816 divided by 200. So I'm getting 29.08. We can take it as 30 number. Okay. And plus 1 we have to do. So it will be 31 number of stirrup is required. Finish. You don't have to do like S1 and S2 zone. In that case, in your Excel sheet, you just write only one thing. In the Excel sheet, you just have to write stirrup in that and that beam. You don't have to write S1, S2. In one line only, you'll find the BBS for the beam. Okay. Got it? No? Sometimes that also happen. Sometimes people will not divide it if it is not falling in the earthquake zone, and if there is no need of that, throughout they are going to give the same spacing like they did here. Similarly, in this beam also you see 2 leg 8 die at 150. So you just find this clear span and that you divide by 150 plus 1 will give you the number of stirrup. Okay, got it? Whereas here it was different. Here also, here what will happen? Two leg 8 at 150 on the left side, 150 on the right side, but middle it was 200. So based on the beam, you have to do it. So that is why I taught you to prepare the Excel sheet. So if you learn to prepare the Excel sheet, then you can do it. And if you copy the same Excel sheet, it will not work out, because Excel sheet, you cannot have a constant Excel sheet. This Excel sheet is not a master Excel sheet. You have to prepare your own Excel sheet. So all the BBS is project specific. Whatever is the requirement of a project. Now we solve the side face reinforcement. So for that, you'll prepare Excel sheet according to that for the side face reinforcement. Got it? Now you know to prepare the Excel sheet, so your job will be very simple. Yeah. So I think with this, we have completed the complete beam BBS. There's nothing left. In spite of this, if you still have any doubt, not able to follow or not able to understand anything, always you can get back to me on this number. I always tell +91 is the Indian code. You 9953779047. Or if you don't, you cannot WhatsApp, you can AKSHAY KMATH73@gmail.com. If you do, I'll solve your doubts. You can ask any questions over there. If you want to send the images, or if you want to, send me questions, like if you have a drawing, if you want to verify whether the answer what you have done is correct, I always suggest you to WhatsApp me the image and write a question. I'll give a solution over there. Or even in the chat box in the Udemy, or here you can do, I'll solve there also. No problem. 9953777905. Great. Akshay Kamal 73 Gmail. Good. So do practice all these things. Try to visualize, try to understand how the beam BBS will be done. It's very simple, right? We'll see you back in the next lecture. Thank you.